Hi. We are given two dates in vector format, and we are to determine what the relationship in time are, whether one is before the other one, that then we have to give the result -1, whether one is after the other, then we have to give 1, or whether they're the same, in which case we have to return 0. There are different ways to approach this, but I'm going to go at it with date manipulation in order to show the tools we have available. One fun thing we can do in Dialog APL is to use .NET. I've prepared some test cases here. It's always the same date on the left, but 3 different dates on the right. And we're supposed to say that the first one is earlier, because we can see here it's the same date, but it's an earlier time, 12 instead of 16. These are exactly the same, and this one is a little bit later because it is a different year. So, in order to use .NET, we have to set our using statement. Let's put in our arguments first, and then we create a little defen or lambda to compare each one of these on the left with each one on the right. We can try this. So this pairs them up. The first thing we have to do is set our using, and we want to use the .NET system, so we write that. And this gives us access to a namespace called datetime. In datetime, we can do various things. There's some functionality that we can use, and we can also create datetime objects, whereas these are just normal APL vectors. We can create scalar entities, which are times. So we can create a new datetime based on, say, the left argument. So they're now formatted for human consumption, but they are just scalars. We want to do that on both of them, so we create a little inner lambda that we can apply to each one of the left argument and the right argument. Now we have two datetimes. We cannot compare them directly, but we can, in the datetime library, we have something called compare. And this compares these two. And this gives us the result that we want. Using .NET is great, but a lot of functionality comes built into APL as well. In this case, we can use something called quaddt, which converts between time formats. And it understands that we have a vector format, and we just want to convert it to a serialized number, which progresses through time, so that we can do a comparison. So these are the day numbers. It's actually the number of days since the last day of 1899, but that doesn't really matter, and we could use any such format that has an offset from an epoch. And now we can compare these two. If we subtract them, one from another, then we find the number of days between them. And we're not interested in how long this is, we're interested in which direction does it go. Is it before, the same, or after? So we can use the signum or sine function to get the result. So this also solves the problem in a much neater way. We can restructure this function a little bit and make it tacit instead of explicit by observing that the main operation here is actually a subtraction. We don't want to subtract the arguments, we want to subtract the date time in format number 1 of each one of them. So another way we can express this is that we want the subtraction over, that is, we preprocess both arguments first with the conversion of the entire vector to format number 1. And then this is a toTrain, or in the top. And we can give it a name without the outer parenthesis. Thank you for watching.